And so you'd get like A sine B, and that's over sine A is equal to B. So we multiply both fractions by sine A sine B. So we multiply both sides by the same thing. Anything we can simplify there? Yeah. And now divide both sides by AB. What do you get? So if I was to divide both sides by AB. Yes, so those two A's cancel, those two B's cancel, and that shows that you can write it that way. So the way you were doing sine rule before was you had the sides on top and the sine of the angles on the bottom. You can also have the sine of the angles on top and the sides on the bottom. This one up here, so put the sides on top if you're trying to find an unknown side. Put the angles on top if you're trying to find an unknown angle. Both will work in both cases, but it just makes it easier. No, angle on top if you want to try to find unknown angle. Okay, let's try this one. Mm-hmm. 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 Okay. Okay. And so it's 1 decimal place. Right, degrees. And that's at 56.3. What number calculator do you have? Okay, yeah, that's fine. Just because with my calculator I can just solve it like that. Okay, great. So it was an unknown angle, and so we put the angle on top. Okay, let's try this one. Mm-hmm. Yeah, so this seems like we have to find an angle first. Over sine x. And so because we're trying to find an unknown angle, what might make it easier? Yeah. Yeah, so just flip both sides so that the angle... Mm-hmm. Okay, so 30. So x is 34.5 degrees. Okay, what is that angle x that we just found? What angle is that actually? It's not called x on the diagram. So that's L. Okay, so that's... Now that you have two angles, how can you find the third? Mm-hmm. So that's 9.5. And now how can we use that? What is x? So let's just call it ln. Mm-hmm. Well done. Well done. And that's the length of ln. 3.73, and that is centimeters. We'll take a look. 3.73, well done. 5 marker. So this one used both. I like this question. You had to do the sine rule with the angle on top, and then you had to do the sine rule with the side on top. Yes, and yeah, okay. Any questions there? Okay. Yeah, let's do this one. Why is that? How do you get area of a triangle? That is area of a sector. Okay, we'll get there. Let's get this angle D, because you're right. That's a blank we can fill in. Mm-hmm. Mm-hmm. Let's say to 3 decimal places. What would it be? Say 3. Okay. Okay. So now we have that unknown. What's next? So the area of a triangle, do you remember how you'd find it? Yeah, so it's a half times base times height. And if you don't know what the height is, height is equal to A sine C, A times sine C. And so it's a half times B times A sine C. And they usually put them alphabetically, A, B sine C, it's the same thing. What that means, so A, B, and C, it's basically any 2 sides and sine of the angle between them. Yep. Yeah, any 2 sides. That's D. It is 2 sides and the angle between the 2 sides you picked. Yes. Mm-hmm. Okay. Mm-hmm. And so to 3 sig fig. 21.9 centimeters squared. Let's take a look. Oh, hang on. It's a parallelogram. We found the area of one triangle. And so how would we get the area of the parallelogram? Yeah. So it's a parallelogram with a diagonal. And so these 2 triangles are congruent. They're identical. you've got three sides the same, side, side, side. And so to 3 sig fig. So that's 43.9 centimeters squared. That's 43.9. That's it. Let's see. So the area of a triangle is a half times base times height. Or if you don't know the height, it's a half times AB sine C, where it's any two sides and the angle between the two sides. Yeah, any questions about anything there? Okay, and I just forgot that actually we only found the area of a triangle and not between. So what would you give yourself for sine rule for 5 markers? How do you feel about that now? Yeah, that's 5 markers, tricky one. This one, I'm not going to bother. It takes a long time to prove this thing. Maybe it's not too long, but you can prove it. You're given this formula. Cosine rule looks a bit like Pythagoras. A squared equals b squared plus c squared, except it's got minus a bit at the end. Yeah. So with the area, well, we proved the area one, we proved the sine rule. You can also prove the cosine rule by going through these steps, and it just shows that the side a squared, to get that, you do b squared plus c squared, so the other two sides squared, and then take away 2 times b times c times cos a. The important bit is that the side you're trying to find is opposite the angle that you're using. So side a, cos a. That's the important bit. The other two sides. No. And that's why I'm not. I mean, proving the sine rule doesn't come up either, but you know, it only took us a second, so. Okay, let's try this. Well done. And so is side AB 180.04 meters long? Well done. So that is 13.4 meters. 13.4, 3 marker. How about this one? Mm-hmm. Mm-hmm. Yeah, 3 sig fig. Yeah, 15.0. And so we could have also used the cos rule for this. You did it in a smart way. Hang on, where did I go wrong here? 2 sides, an angle between. Oh, and I have to square root it. So if I square root my answer, and I get 15.0 as well. And so whichever way you do it, you're going to get the same thing. That's going to be fine. So 3 markers. I think you're very good. Correct. Yeah. And so that's kind of what I was expecting you to do that, but instead you did the angles. But sine rule is easier than cos rule, and so yeah, I'd use it if you can. Okay, let's try this one. Mm-hmm. Yeah. And what is the side B, are you talking about? Nope. It is 2 sides and the angle between them. And so what two? Yeah, and so just so. Well done. No, you're trying to get CB. Yeah. Well, use your calculator. Uh-huh. Okay. Yeah, so. Okay. And you can use answer if it's. Yeah. 31.1 meters. 31.1, so that's a 5 marker. It's very common for them to put the area of the triangle with the cos rule because both involve two sides and the angle between. So two sides, angle between, that is going to be area and cos rule. The sine rule is to do with a side and the angle opposite it. Or basically sine rule would be every other situation involving a scalene triangle. So any questions about any part of that? Well, you're doing well. No, you're doing well. Let me see. So the area of this one. Okay, so this one we were given a side and an angle. Now we're given two sides. Okay, let's try this. Yeah. Okay, what's next? Try it. Mm-hmm. Nope. What does cos rule get you? Or what is the cos rule? Yeah. Mm-hmm. Mm-hmm. Yeah. So it's two sides and angle between. Yeah. .64 centimeters. It will work, but you don't need to, because on a right angled triangle, you'll have the sine of 90, which will be 1. And so if you divide by 1, just stays the same. And so, and then the same thing if you have, let's say, the cos of 0, you will be subtracting that. And that's 1 is, yes, or you're, no, not cos of 90, sorry. You'll be subtracting that, and that's 0. And so you're just subtracting 0. So if it's a right angled triangle, it just becomes a squared equals b squared plus c squared, which is just Pythagoras. And with the sine rule, it just becomes SOHCAHTOA. And so you'll end up with the same answer, but you'll just be doing a little extra work. And so if it's a right angled triangle, you use a half times base times height for area. You use Pythagoras for length and SOHCAHTOA for angle. It's only if it's not a right angled triangle. So if it's just a scalene triangle, any triangle in general, you have to use the more difficult area sine rule and cos rule formulas. Yeah, but if you were to use the cos rule, you would still get the same answer. Like when you did the sine rule and I did the cos rule, you get the same answer because it's the correct answer. There you go, back. So any other questions or anything there? Okay, so in general, if it's a right angled triangle, just use the simpler ones, SOHCAHTOA, Pythagoras. If it's a scalene triangle, then it's going to be the harder ones. And two sides and the angle between, that's going to be cos rule. Anything else, sine rule. This is a tricky one. Tricky. Just want to see, it's more of a, that one's going to be okay. Will any of these challenge you? So this is a 6 marker, but it seems like it's the same. That one might be different. Yeah. I think you're mostly good for these, but let's just do the real challenging ones. Okay, let's go for this one. I think it's that. Yeah, it's way too much missing. So area, we don't know the area, so that doesn't help us. So we need So to get TR, we would need like two sides and an angle minimum. At the moment we have one side, so I need at least another side and an angle. So how would we find a side or an angle? Mm-hmm. Yeah. What does this angle appear? Therefore, do the same you did on this side. This one. So it's, well, a straight line is 180. This total is 160. This part is 90. And so this part. Mm-hmm. Great. To just do one more decimal place. 615. Okay. Gives us plenty. Yep. Um, six kilometers. And sorry, to one decimal place it's 6.2. One decimal place, 6.2 kilometers. Great. And the reason why I told you to do it to one extra decimal place is because if they want the final answer to one decimal place, then do the working out to 3 decimal places. Or you can just use the answer key, but sometimes you have to do something else and so you lose the answer. So this one, I wasn't sure how you would do it, but it's one of those where you just kind of fill in enough blanks until you kind of get there. I think the big one was once you got the 60 down here, then you could see the sine rule. and that gave us this final side of this triangle, and so that's all we needed. But yeah, so on the right side you said, well, this is 90 and this is 50, and so just keep doing that. On the left side, this is 90 and this is 70, and just keep filling in blanks until you get to the point where you can do it, because, well, you know, it's not always obvious where to begin. Do you have any questions about this one? Okay, so let's so this is similar to the one we did. Similar. I just want to do 1/6 marker. I just want to pick as challenging a one as I can. So my guess, so we did a type like this, where you're given the area, you're given two sides, and you have to find it. We did one like this, two sides given the area. We did one like this, side and angle given the area. And so this is the only type we haven't done yet. Let's do this 6 marker. So let's say 5 sig fig, so one more. Okay. And what side or whatever did we just find with that one? Okay. Centimeters, that's 3 sig fig. 5.82, 6 marker. Yeah, so this one was a mixture of cos rule and sine rule, which we're good for. We've done mixtures of area and sine rule, and area and cos rule. No question has come up on any exam paper that mixes all three. Probably because it would be worth too many marks. Like, they tend to not have 7 mark questions or anything like that. So let's see. I'll just do a recap. So when do you use a half times base times height? When do you use the half AB sine C? Yeah, so let's even do it this way. Okay, so right angled triangle. That one is a half times base times height. And then this one is a half AB sine C. What if you have to find, so what else do you use? What thing do you use when for each one? And this angle A, where is that in the triangle? That's it. So angle A is between B and C. And where is it in relation to A? Yes. Okay. Yep. And just in practicality, we never need a third thing all in one go, but you're right. When would you use this form of the sine rule? And does the sine rule take any other form? Sometimes it looks different. And when does it flip? That's it. So yeah, both will work both times, but there's two less steps if you just do that from the beginning. That's unknown side. That's for an unknown angle. And can you think of one more thing for right angled triangles when you need to find an unknown side? Yeah. Great. That's cos rule. That's that. And that's the same thing. So like you said down here, this angle, so that's any two sides and the angle between. And we did, the most challenging exam questions. So how would you feel now about the higher trig, cos rule, sine rule area? So also, yeah. Yeah. Equals c squared. And yeah, so you can see how if you have the cos of 90, it's 0. So that's like minus 0, which so you end up with Pythagoras anyway. It's kind of where it comes from. Yeah, how was that for you, Hugo?